Now, methods of solving first order, first degree differential equations. See here we have in this three types of differential equations. One, we can solve the differential equation by variable separable method. Second one, we can solve the differential equation by homogeneous, which are homogeneous differential equations. These are having separate, same variable separable only we have after doing some minor adjustments in the beginning. And third one is linear differential equations here. So these are all the three first order, first degree differential equations, these three. See, these are the different types of methods by which you can solve the differential equation. See here, now we are going for first method, first type, that is variable separable method. In this method, what we are going to do, you can see the problem here he has given. dy by dx is equal to 1 minus cos x by 1 plus cos x. He has given this. Now, here variable separable means all variables which are of y, they must be separated, and all variables which are of x, they must be separated separately. So thereby dy with y variable, dx with x variable are all separated here. Now here he has given 1 minus cos x by 1 plus cos x. 1 minus cos x by 1 plus cos x. Here you can see dy by dx I have written as it is here is equal to 1 minus cos x, we know the formula is 2 sin square x by 2 divided by 1 plus cos x, we know it is 2 cos square x by 2. This 2 and this 2 get cancelled. Sin square x by 2 divided by cos square x by 2 is tan square x by 2. Now what we are going to do? Now dy by dx is equal to tan square x by 2. See, this contains x variable. Therefore, this I am going to group it with this. So, dy by dx is equal to tan square x by 2 can be written as secant square x by 2 minus 1. As it is, you cannot integrate this. So that is why we are using this formula secant square x by 2 minus 1. And dy is equal to, I am just transferring this dx to this side. So secant square x by 2 minus 1 into dx. Now integrating both sides. Integral dy is equal to integral secant square x by 2 minus 1 into dx. Now what is integral dy? It is y. This is equal to, see here, it is secant square ax dx. Integral secant square x ax dx is 1 over a tan ax. You can see here. Secant square x by 2. A is here half. So 1 over half is 2. Tan ax means tan x by 2. So 2 tan x by 2 minus integration of dx is always equal to x plus a constant. So y is equal to 2 tan x by 2 minus x plus c is the solution for this problem. Here you have to understand here. See, this 1 minus cos x always it is equal to 2 sin square x by 2, because half angle we are going to say. That is why we have written here. Similarly, 1 plus cos x, it is an half angle, 2 cos square x by 2. That is how we get this tan square x by 2. But tan square x, tan square, you can write here, tan square x is equal to secant square x minus 1. We can write like this. So instead of x we have x by 2 here. Therefore we have written, instead of tan square x by 2 we have written secant square x by 2 minus 1. That is how it has been written, and the problem follows. Now we will see second problem. dy by dx is equal to 1 plus x square into 1 plus y square. See, this y and 1 plus y square we are grouping. That is dy by dx is equal to 1 plus x square, 1 plus y square. This 1 plus y square I am bringing it down, and this dx I am putting it here. Therefore dy by 1 plus y square is equal to 1 plus x square into dx. So we are integrating both sides. Integral dy by 1 plus y square is equal to integral 1 plus x square into dx. Now, integration of, you can see here, integration of dx by a square plus x square is equal to 1 over a tan inverse x by a. You can see here, dx. Here you can see a, instead of a we have 1 square. So 1 over 1 is 1 only. So tan inverse x by a, tan inverse y by 1. Tan inverse y by 1 is y only. So tan inverse y is equal to, now differentiate, dx into x, dx into 1 is x plus x square into dx, 2 plus 1 divided by 2 plus 1. X to the power of 2 plus 1 is 3, x cube divided by 3. So x plus x cube by 3 plus c is a constant. So, but here we have to be very careful. This we have to use this formula for this, tan inverse y. So tan inverse y is equal to x plus x cube by 3, group it, plus c, a constant. That is the answer to this. Now, third problem, dy by dx is equal to sine inverse x, or dy is equal to sine inverse x into dx. So integrating both sides, integral dy is equal to integral sine inverse x dx. But as it is, this integration is not possible by ordinary method. See, for that what we do it by this method, uv dash sine inverse x into 1 into dx. Here we are going to take the inverse function sine inverse x as u and 1 as v dash. Therefore u dash is equal to 1 over root of 1 minus x square. V is equal to integration of 1. Integration of 1 is x. Therefore here what we have done this problem, integral uv dash is equal to uv minus integral vu dash. That is what we have done here. uv is what? uv, x sine inverse x minus integral vu dash, v is x divided by root of 1 minus x square. U dash is 1 over root of 1 minus x square into dx. Now x sine inverse x minus, now here how to solve this integration? We are putting 1 minus x square is equal to t, minus 2x dx is equal to dt, x dx is equal to minus dt by 2. That is what we have done here. Minus into minus becomes plus of, I have taken out, 1 integral 1 over root t dt. Root 2 dt is nothing but t to the power of minus half plus 1 divided by minus half plus 1. That is of t to the power of half divided by half of get cancelled. X sine inverse x plus t is what? 1 minus x square. Half means root. So root of 1 minus x square. Therefore, ultimately, what is the problem now we have here? Integral dy is equal to integral sine inverse x dx is equal to y. Integration of dy is y is equal to integration of sine inverse x, what we have found out here? X sine inverse x plus root of 1 minus x square plus c. That is what we have done here. That is the answer. Now, this fourth problem, y log y into dx minus x into dy is equal to 0, or y log y into dx is equal to x into dy. Now, dy by y log y is equal to dx by x. Integrating both sides, dx by x is equal to integral dy by y log y. This right hand side, put log y is equal to t. 1 over y dy is equal to dt. 1 over y dy is equal to dt. Therefore, dt by integral dt by t. So this is log x is equal to log t plus c, or log x is equal to log of t is what we have kept here, log y plus log c. Instead of c we can write log c. Absolutely no problem. So log x minus log of log y is equal to log c. Here you can see log m minus log n is log m by n is equal to log c, or this log and this log get cancelled. X over log y is equal to c, or x is equal to c log y to the base e, or x by c is equal to log y to the base e. Therefore, y is equal to e to the power of x by c. So, this is the answer for this. Now, we shall see this fifth problem. It is a very typical problem here. What he says, x into x square minus 1 dy by dx is equal to 1, where y is equal to 0 and x is equal to 2. Find a particular solution to satisfy the given condition. See, this is very important here. See, x into x square minus 1 dy by dx is equal to 1, or dy is equal to dx I have taken to this side, x into x square minus 1 I have taken down. So dy is equal to dx over x I have written as it is. This is a square minus b square, a plus b into a minus b, that is x minus 1 into x plus 1. Now, therefore, integrating both sides, integral dy is equal to integral dx over x into x minus 1 into x plus 1. See, this particular RHS is a partial fraction method. We have to integrate by partial fraction method. That is, that we have shown it separately here. This method we have shown it separately here. Dx over x into x minus 1 into x plus 1 can be split into a over x plus b over x minus 1 plus c over x plus 1. Now, 1 is equal to, see here, x into x square minus 1 I have taken LCM. Now here it becomes a into x square minus 1 plus b into x plus 1 plus c into x minus 1. Now by putting x is equal to 1, this goes 0 and this is also 0. Therefore b we get b into 1 plus 1 is how much? 2. So 2b is equal to 1, therefore b is equal to half. Similarly, put x is equal to minus 1. Here when we put minus 1, this goes. And this also goes. Only c you get. So 1 is equal to c into minus 1 into minus 1 minus 2, minus 1. That is minus 2 into minus 1 is plus 2. So 2c is equal to 1c is equal to half. Now equating all the coefficients of x square, a plus b plus c. There is no coefficient of x square here, that we have put 0. So a plus b plus c is equal to 0, or a plus b is half plus c is half is equal to 0. Half plus half is how much? 1. So a plus 1 is equal to 0, a is equal to minus 1. Now, again coming back here, what we are going to have split like this, So integral minus a is 1, minus 1 over x into dx, plus b is half into integral dx by x minus 1, plus c is half integral dx over x plus 1. So this is minus log x plus half log x square minus 1, because log of x minus 1, log of x plus 1 is log of x square minus 1. So half log x square minus 1, or minus log x square plus log x square minus 1, or 2y is equal to this half. I am going to take this here. 2y is equal to log of x square minus 1 divided by x square plus c. Now, put these values now, that condition, we have to satisfy that condition. Therefore, put y is equal to 0 and x is equal to 2. I am putting y is equal to 0. Here, log of 2 square is 4. 4 minus 1 is how much? 3. Divided by 2 square is how much? 4. Plus c. Therefore, c is equal to minus log 3 by 4. Therefore, 2y is equal to log of x square minus 1 by x square minus log of 3 by 4. This is the answer for the problem. Now, sixth problem. Here, we have find the equation of the curve passing through minus 2, 3, given that the slope of the tangent to the curve at any point xy is 2x by y square. Now, slope of the tangent is given by the formula dy by dx is equal to 2x by y square. Dy by x is equal to 2x by y square. Now cross multiply. Dy into y square is equal to dx into 2x. Now integrating both sides, we get integral y square dy is equal to integral 2x dx. Now this is 2 plus 1 divided by 2 plus 1. Y cube divided by 3 is equal to x square by 2. This 2 and divided by 2 get cancelled. X square plus c. See here is given points are minus 2 and 3. That is when x is equal to minus 2, y will be 3. So I am substituting that value. Y is equal to 3 cube divided by 3 is equal to minus 2 whole square plus c. Or 9 is equal to 4 plus c, or c is equal to 9 minus 4, that is 5. Therefore, equation of the curve is equal to y cube by 3 is equal to x square plus 5. Now cross multiply. Y cube is equal to 3x square plus 3 into 5, 15. Therefore, y is equal to 3x square plus 15 whole to the power of 1 by 3. This is the equation of the curve. We get. Now, find the equation of the curve passing through the point 0, minus 2. Given that at any point xy, the product of slope of its tangent and y coordinate of the point is equal to the x coordinate of the point. See here, you can see this figure. Slope of the tangent is dy by dx. The product of slope into y coordinate, product of the slope is dy by dx. Y coordinate is this. So y into dy by dx is equal to x coordinate is this. What is x coordinate? This is x. So y into dy by dx is equal to x. Therefore, y into dy is equal to x into dx. Now integrating both sides. Integral y into dy is equal to integral x into dx. Or y square by 2 is equal to x square by 2 plus c. Here, when x is equal to 0, what is the value of y? It is minus 2. Substituting that value here, minus 2 whole square is 4. 4 divided by 2 is equal to x is 0. 0 plus c. Therefore, 2 2s are 4. c is equal to 2. Therefore, y square by 2 is equal to x square by 2 plus 2. Or y square is equal to x square plus 4. 2 2s are 4. Therefore, y is equal to square root of x square plus 4 is the equation of the curve. Now, this figure you can see here. See, whenever there is a curve, this we have a point xy is s. So given that at any point xy, that is what we have taken here, the coordinate y coordinate is y and x coordinate is x. Therefore, when we multiply both slope and y coordinate, that will be equal to x coordinate. That is what we have done here. So that is being depicted on this curve. Now this last problem, 8th problem. In a bank, principal increases continuously at the rate of 5% per year. An amount of ₹1,000 is deposited with this bank. How much will it worth after 10 years, he asks. That means to say, here solution, let P be the principal at any time t. At any time t. Now as per the problem, dp by dt is equal to 5%, you know. So 5 by 100 into p. Or dp by dt is equal to p by 20. 5 ones are, 5 20s are. Now what I am going to do, separable, we have to separate the variables. dp by p is equal to dt by 20. Or integral dp by p is equal to 1 over 20 integral dt. Integrating both sides, we get this. So log of p to the base e is equal to t by 20 plus c. Now, therefore p is equal to, see here, this goes, p is equal to e to the power of t by 20 into e to the power of c. when P is equal to 1000, time will be 0 at that time. Therefore, P 1000 is equal to e to the power of 0 into e to the power of c. But e to the power of 0 is 1. So e to the power of c is equal to 1000. Now the equation becomes P is equal to 1000 e to the power of t by 20. 1000 e to the power of t by 20. Now when t is equal to 10 years, we have to find out principal. So P is equal to 1000 into e to the power of t is 10 years, 10 by 20. That is 1000 into e to the power of 0.5. But e to the power of 0.5 is 1.648 value. Therefore 1000 into 1.648 will give you principal after 10 years is 1648 rupees. So principal is rupees 1648 after 10 years.